In this video, we'll learn one more way to depict stereochemistry in 2 dimensions. So far, we've really been indicating stereochemistry, or R and S configurations, with our wedged dashed drawings. But there is another formalism that we can use that flattens out these structures to depict them in 2 dimensions, and that's a Fischer projection. In a Fischer projection, we draw the 4 groups around a chiral carbon as a cross. And in this cross, there's a formalism that the top and bottom positions, the vertical positions, are pointing back away from the viewer. And the left and right positions, the horizontal positions, are pointing toward the viewer. So this structure on the slide really means that in 2 dimensions, the bromine and hydrogen are coming toward the viewer, and the methyl and ethyl groups are pointing back away from the viewer. So converting this picture now to our typical skeletal line drawing, we can rotate the structure in our minds so that the methyl is on the left and the ethyl is on the right. That puts the hydrogen back and the bromine forward. Rotating the structure in your mind might still be tricky, and that's okay. Make a model to help you see that these 2 drawings are depictions of the same structure. I have a model here that we can use, and the orientation of the Fischer projection is looking down this carbon between the hydrogen and the bromine, where the methyl group and ethyl groups are pointing back, and that puts the bromine forward into your left and the hydrogen on the chiral carbon forward into your right. Okay. When we convert this to a skeletal line drawing, we're really just viewing it from this side. Okay. We're viewing it from the side with the bromine, so sort of looking down this direction. So we can turn the structure so that we're viewing it from that side. And then we rotate this 1 bond so that we have our typical zigzag carbon chain here. And then we see that the bromine is pointing toward you and the hydrogen on the same carbon is pointing back away from you. The methyl group is to your left, and then this ethyl group is to your right. The other thing to note here is that because we're orienting the molecule with 2 horizontal groups pointing forward and 2 vertical groups pointing backward, there's more than one way to achieve this orientation, meaning there's more than one correct Fischer projection for any given molecule. Here I'll just show you an example of a second correct Fischer projection for R2-bromobutane, the structure we've been looking at. I can orient the structure so that the ethyl group is pointing up and back, and the methyl group is pointing down and back. And we're looking at this chiral carbon, the same chiral carbon, and this orientation puts the bromine now to the right and forward, and the hydrogen to the left and forward, giving us a second correct Fischer projection. Let's try one now. Convert each of the molecules shown here into a Fischer projection. To do this, all I have to remember is that in the Fischer projection, the vertical groups are pointing back and the horizontal groups are pointing forward. So I like to start with the skeleton in place before I do anything else. Okay, then to place my groups on that skeleton, I need to reorient the structure in that fashion. And here the easiest way for me to think about this is as if I'm looking down the molecule. I'm sitting above the OH group and looking down between the OH and the hydrogen. And when I do that, the methyl and propyl groups are pointing down, so I need them on the vertical positions. I'll put the methyl on top and the propyl on the bottom. In that case, it places the OH on the right and the hydrogen on the left. And then I just need to flatten it. Remember, there are no dashes and wedges in a true Fischer projection. The up and down positions are defined by the horizontal and vertical positions. So we just flatten out the structure into the 2-dimensional depiction on the bottom. In the second example, I'll view this as if I'm looking down between the methyl and the bromine. This is sort of right to left here. And in that case, the methyl and bromine are pointing up towards me. So they need to be on a horizontal. I'll place the methyl on the left and the bromine on the right. Then from that vantage point, that puts the hydrogen and fluorine pointing back away from me, with the hydrogen on the top and the fluorine on the bottom. Then again, we need to remove our dashes and wedges to get our final Fischer projection.